We are going to start the new topic, stationary point. In the stationary point, then we will discuss about maximum and minimum points, and then stationary points of inflection. First of all, we are discussing about the stationary point. That what is stationary point? This is XY plane. In XY plane, first of all, we are drawing a curve. As before this topic, we were differentiating different type of function, like function y is equal to, generally we were differentiating y is equal to f of x, and derivative of y with respect to x, we were taking dy by dx. Here y is dependent and x is the independent variable. Now this y is equal to f of x, we are sketching here in xy plane. Suppose this is y is equal to f of x. Y is equal to f of x. Now, here we are describing this portion of the curve up to this turning point with the different color. Then this point, turning point, we are mentioning P. This is the turning point we are mentioning here, Q. And this is also the turning point we are mentioning, R. Then from P to Q, this portion of the curve I'm describing here with the different color, with the green color. Again from Q to R, this portion of the curve again red, and from R onward, this portion again green. Okay. The red section of the curve shows where gradient is negative, as this is change of y with respect to x, mean dy divided by dx. Rate of change of y with respect to x is along x-axis, this is x, along y-axis, this is y, and this change is decreasing. This change is decreasing. It means this gradient will be negative up to this turning point P. At P, there is no change. No change mean then dy divided by dx will be 0 at the turning point. Derivative will be 0, mean gradient is also 0. Okay, is at the red portion of the curve, gradient is negative. At P, gradient is 0. Then after that, the green portion of the curve, again it's increasing. Increasing mean dy divided by dx is positive, okay, greater than 0. Again for the red portion, dy divided by dx is negative, less than 0. At point here at point Q, again gradient will be 0 at this turning point. Okay, here gradient will be 0. And at R, again gradient will be 0. dy by dx will be 0. Rate of change is 0. Then after that, at this green portion, again dy by dx mean first derivative will be positive. Okay. Now here you can see on all the turning points, gradient is 0. Where gradient is 0, dy by dx is 0, that will be the turning point or the stationary point on the curve. This stationary point we are describing, this stationary point or the turning point where dy by dx will be 0. This dy by dx will be equal to 0 on the stationary point. stationary point. Now, how we can check that turning point is maximum point, this stationary point is maximum point or minimum point? Here, this maximum and minimum points. If for that thing here, I'm describing here with the new diagram. Suppose curve is like this. As in these type of curve, this is the turning point. How we will check that this is maximum point or minimum point? Before the turning point, this I'm describing with the green color, and after the turning point, this portion of the curve I'm describing with the red color. You can see here, before the turning point, it's this portion having gradient positive, dy divided by dx greater than 0. Okay, it's positive. At the turning point, always will be 0, dy divided by dx 0, and after the turning point it's decreasing. Then after the turning point, this dy by dx means gradient is less than 0, negative. If left to the turning point gradient is positive and right to the turning point gradient is negative, then turning point will be maximum point. Then turning point will be maximum point. Now, one more curve here I'm showing is here before the turning point. I'm representing here with the red color, and after turning point representing with the green color. This is the turning point. Now again you can see here, before the turning point dy by dx is negative, mean rate of change is negative, derivative negative. At the turning point dy by dx will be 0, and after turning point as gradient is positive, when gradient is turning from negative to 0 and then positive from left to right, okay, then point is minimum point. As you can see here in this graph, point is minimum point. If gradient is turning, mean this first derivative is turning from positive to 0 and then negative, then turning point is maximum point. And if gradient is turning from negative to 0 and then positive, then turning point is minimum point. If you are taking curve like this, or like this, here on this curve, you can see before this stationary point, this is the stationary point where gradient is 0, mean parallel to the x-axis. Before the stationary point, dy by dx is positive. Dy by dx is greater than 0. At the stationary point, dy by dx equal to 0. After stationary point, at this portion, again dy by dx is positive, mean in the same way, positive. If gradient is turning from positive to 0 and then again positive, here this is positive, here 0, then again positive, or gradient is turning, here gradient is negative, it's decreasing downward, dy by dx less than 0. Here at the stationary point, dy by dx will be equal to 0, and after that here on this portion of the curve, again dy by dx decreasing less than 0, are here gradient is converting from negative to 0 and again negative to 0 and again negative. This third type of stationary point is called point of inflection. Then this turning point is called point of inflection. Second derivative, new topic is second derivatives and the stationary points. How we can use the second derivative to find the stationary points? For that, again, we will describe here with the sketch. Suppose this curve is here. In second derivative, we will take the rate of change of dy divided by dx. Rate of change of dy by dx mean second derivative. One more derivative we will take of dy by dx. As here in these type of curves, this is the stationary point. Before stationary point, this is positive, and this is the stationary point. Then after stationary point, gradient is negative, rate of change is negative. As dy divided by dx here is positive, okay, then here dy by dx is 0, and here dy by dx will be negative. Then again we will check the rate of change of dy by dx. As dy by dx is here positive to 0 and this side negative, it's decreasing. Look, from positive 0 decrease, 0 to negative, more decreasing. Okay, more decreasing. It means this d2y divided by dx square is less than 0. But here, a dy by dx at the stationary point, it should always be 0. Then we can write like this: if dy divided by dx is equal to 0 and d2y divided by dx square, as there I've shown that less than 0, then point is the maximum point. Here in this curve, you can see this turning point is the maximum point. Then point is maximum point. Now for minimum point, how we will check? This is the curve. At this curve, before the turning point, here up to here, dy divided by dx is negative, less than 0. At the turning point, dy divided by dx equal to 0. This after turning point on this portion of the curve, dy divided by dx will be positive. As here you can see gradient rate of change in dy by dx from negative to 0 and then positive. Okay, from negative to 0 and then positive. Then we can write like this: if dy divided by dx mean first derivative 0 at the turning point, then that turning point, and one more thing, d2y divided by dx square mean rate of change of dy by dx is positive, then the point is minimum point. Then the turning point is minimum point. This is the way to find with the help of second derivative that point is maximum point or minimum point. Mean the nature of the point we can check with the help of second derivative like this.